There is a planet in our solar system that has been hiding in plain sight. We've studied it for 400 years. We've sent spacecraft to orbit it. We've named its moons. We thought we understood it. We were wrong. Jupiter isn't just a giant ball of gas. It's something far stranger, far more violent, and far more important to your existence than you've ever been told. Here's what most people know about Jupiter. It's big, bigger than every other planet combined. You could fit 1,300 Earths inside it. Its mass is so enormous that it doesn't technically orbit the Sun. Both Jupiter and the Sun orbit a shared gravitational point called a barycenter, a point that sits just above the Sun's surface. The Sun itself moves because of Jupiter. You were taught that Jupiter is a gas giant. Hydrogen, helium, clouds, storms. The Great Red Spot, a storm wider than Earth itself, spinning for centuries. It sounds remarkable, but that's not the full story, because what's underneath those clouds is where everything changes. Beneath Jupiter's visible atmosphere, the pressure begins to climb, the temperature rises, and something happens that should not be possible on a planet. Go deep enough, and hydrogen stops being a gas. It stops being a liquid. It becomes something that has no equivalent on Earth. Metallic hydrogen, a state of matter so extreme that hydrogen, the lightest element in the universe, begins to conduct electricity like a metal. Jupiter doesn't have a surface. It has layers, each one more violent than the last. And this is where things change. That ocean of metallic hydrogen generates something critical. It generates Jupiter's magnetic field. And Jupiter's magnetic field is not like Earth's. It is the largest structure in the entire solar system. If you could see Jupiter's magnetic field with the naked eye from Earth, it would appear 5 times larger than the full moon. Think about that. A structure billions of kilometers wide, invisible, surrounding us right now. The real story begins here. Jupiter's auroras are not like ours. They are permanent. They never stop. They are powered not just by the solar wind, but by Jupiter's own volcanic moon, Io. Io is the most volcanically active body in the solar system. Its eruptions shoot material hundreds of kilometers into space. That material gets captured by Jupiter's magnetic field, and it accelerates. Particles slam into Jupiter's atmosphere at speeds approaching 200,000 miles per hour. The result is an aurora that releases more energy than all the electricity generated on Earth in an entire year. That's not the part that matters. For billions of years, Jupiter has been doing something no other planet does. It has been acting as a shield. Its gravitational pull is so immense that when comets and asteroids drift toward the inner solar system, toward Earth, Jupiter intercepts them. It captures them, pulls them in, or slingshots them back out into deep space. In 1994, comet Shoemaker-Levy 9 broke apart and slammed into Jupiter. 21 fragments, each one hitting with the force of millions of nuclear weapons. The largest impact scar was bigger than Earth. That comet was on a path through the inner solar system. Jupiter caught it first. Without Jupiter, that conversation changes. This isn't just about a planet. It's about architecture. Our solar system is arranged in a very specific way. The gas giants, Jupiter, Saturn, sit in the outer solar system. The rocky planets, Earth, Mars, Venus, sit in the inner region. Scientists believe this arrangement is not common. When they study other solar systems, they find gas giants in chaotic orbits, plunging inward, clearing everything in their path. In our solar system, Jupiter stayed put. And because it stayed put, Earth had time. Time for oceans to form. Time for chemistry to stabilize. Time for life to emerge. Jupiter didn't just protect Earth from comets. Its gravitational influence helped shape the asteroid belt. It influenced the orbit of every rocky planet. It was, in many ways, a silent architect of everything you've ever known. NASA's Juno mission, which has been orbiting Jupiter since 2016, is still sending back data that rewrites textbooks. The cloud bands that look so clean from a distance extend hundreds of kilometers deep. The ammonia storms that look like brushstrokes from space are three-dimensional systems, layered and complex in ways we didn't predict. At Jupiter's poles, there are massive cyclones arranged in geometric patterns. Stable, organized, symmetrical. We don't fully understand why. A planet 780 million kilometers away, and it is still giving us questions we cannot answer. Jupiter is 4.5 billion years old. It was the first planet to form in this solar system. It formed fast in under 1 million years, before most of the other planets even existed. In a very real sense, Jupiter came first, and then it spent billions of years quietly governing everything that came after. That's not a metaphor. That is the gravitational reality of our solar system. If you've ever looked up on a clear night and seen a bright, steady point of light that doesn't flicker, that was probably Jupiter, the fourth brightest object in our sky. And you were looking at something that has been watching over this solar system since before Earth existed. A shield, a dynamo, a gravitational engine with a magnetic field the size of a star, still spinning, still protecting, still hiding things we haven't found yet. If you want to go deeper into these mysteries, the secrets still inside our solar system, the science that keeps rewriting itself, subscribe, because we are just getting started. We've studied Jupiter for 400 years. We've orbited it. We've photographed it. We've named every storm, and it is still showing us that we don't understand as much as we thought. The most familiar things in our sky are the ones we understand least.